Alright, so today you're going to look at inverse trig derivatives, and these guys are a little bit different because they don't necessarily follow a pattern that we've set up before, but there is a pattern for each one of these guys, and so you want to add this information to your trig card by your other derivative items, okay? And then keep them handy while you're working your math so that you can go back and reference them, okay? And so if you need to pause and do that, pause and do it. I'm going to go ahead and slide into the first example. So we've got this trig function here, inverse trig function, arcsine of x squared. Now the arcsine of x squared doesn't fall into one of our other regular categories, okay? But it does fall into the arcsine category. And you'll notice that for this trig guy right here, we've got a u right there. So u equals x squared. And if you'll notice, we've got a u right here. So I need to know what du dx is. And for this guy, it's not too horribly difficult. Now, we do need to understand that the absolute value of x squared has to be less than 1. Otherwise, this won't work. Okay, think about the largest value you can have for the sine is 1. So the largest value you can have for the arc cosine is 1. Okay, everything's got to be smaller than that. All right, now set your pattern up here. So we're going to take 1 over the square root of one minus u squared times du dx. And so simplify and clean that up, and what you end up with is 2x over the square root of 1 minus x to the fourth. And that's it. That's the derivative of the arcsine of x squared. Okay? That's all there is to it. So, how about you try one? One that's very similar. Like, say, this guy. And see what you get.